Hello. For this lesson, we'll be going over the USACO 2018 December contest, bronze question number 2, the bucket list. Here is the question and the format and sample inputs. You can pause the video and take a look at this. So the basic idea is that Farmer John has N cows. Each of them have a certain time slot that they will be doing the milking process. We guarantee that the milking start times and end time, they don't overlap, or well, they don't. So the start time and end time, they can't be the same. So the timings could overlap, but the start and end time, they are all separate. So taking a look at the inputs, you're given N, which is the number of cows that are going to be milked. So on the next N lines, you're given S, T, and B. So S and T are the start and end times, respectively. And then B is the number of buckets used during the milking process. So given this, you have 3 cows at 4 and 10. So the 4 is the start time, 10 is the end time, and that requires 1 bucket. 8 is the start time on the second one, 13 is the end time on the second one, and then that requires 3 buckets. And 2 is the start time on the last one, and then 6 is the end time, and that gives you 2 buckets. Given all this, what you're trying to find is the total number of buckets needed, the minimum total number of buckets needed to successfully milk all the cows. So let's just take a quick sketch to see how this looks. So if we take the sample input, so given all this, what we have is the starting and end times for the buckets, as well as the number of buckets used during each session. We can see that there is overlap, so between 4 and 6, that requires 3 buckets. Between 8 and 10, that requires 4 buckets right there. And we're just trying to find the minimum number of buckets needed in order for this to work. So one solution you can do is pretend you have an unlimited number of buckets, and you only loan out the buckets needed when Farmer John requests it. So what you can do is, at this time, Farmer John would require 2 buckets, so you would give Farmer John 2 buckets. And then here at 4, that's the start of that, which is 1, so you would loan another 1 bucket. At 6, that is when it stops, so minus 2. At 8, so we're still having that plus 1, so we need to do plus 3. So right now, at this step, we have 2 buckets in use. At this step, we have 3 buckets in use. At this step, we have 2 buckets, or yeah, 1 bucket in use, sorry. And then at this step, we are starting to use 4 buckets. And at this step, we stop using the 1 bucket, so we're back down to 3. And then at here, we obviously have 0 buckets. So 0 at the beginning, which we're going to see here. So we start at 0, and then we move up. And then we give Farmer John only the buckets whenever is requested. So here's when that's requested, another time here, and another time here. And then just remove it when it's stopped. So this allows us to do is just go through the whole list once, just count how many times, based on the timing, whether or not the bucket is needed, and then we just return the highest value, which is this one, since that is the minimum number of buckets needed at this given time. Okay, so let's go ahead and look through the Python code version of that. Okay, so for this one, reading in the file, I read in N, which is the first line. I read in start and end as a dictionary. That allows easy access to the starting and end times. I also request that the start and end time, I include the B value. So going through every single start and end time, reading the lines. Start int S is the key value B. So this is the thing that's being added when requested. And then T is the value when returning. So these are the buckets that are being returned. I also keep track of the max value, or the max value at the end. This just makes it a little bit more efficient than just going through the whole, I guess, 1,000 steps, since I think, yeah, so it's saying right here the range is between 0 and 1,000. This just makes it slightly more efficient, though it's not necessarily needed. You could mostly get away with just using the start and end. Right, so write file, writes the file to the, or writes the answer to the file. And then the solution is fairly simple. There's only one for loop. So decompose the args into the values that are there. Answer is set initially to 0, so we assume that Farmer John requests no buckets. And temp buckets is just a temporary buckets used when giving and receiving the values of the bucket. And then I go through I, so basically at every time step, just check how many buckets are needed. And if it's in the start, that's when you add buckets. And then here's where the temp buckets are needed. So I determine the maximum value between answer and temp bucket. So if the, since we're trying to minimize this, or we assume that we're going for the minimum value. So if anything is added, that means it's going to be required rather than minimized. So in this case, so let's say the current answer is maybe 3 and the temp buckets is 5. Then we know that we need at least 5 buckets in order for this to still work. So that's why our answer gets replaced with temp buckets. Otherwise, we just return the same answer as before. And then if we get to the end, so if we move forward and then choose the end, what we do is look through the buckets, or rather subtract the buckets from the temp buckets, and that reduces the value. The final thing we do is return the string of answers. So the key insight here is that we know that all time steps are separate from each other. The start and end times are separate from each other, so we can guarantee that if there's an end time, then we can return the buckets, and then if there's a start time, we loan the buckets out. And that's why this can be fairly efficient to use, because we don't have to go through every single start and end time, checking against other starting and end time, which would be n squared operations, since we would have to do 2 for loops, checking against everyone. That'll be all for this lesson. Thank you for watching.